Hi friends, welcome back. Today I will explain about the nodal analysis. First of all, what is meant by a node? First of all, node is a point which combines three or more branch points is called a node. Okay, this is a resistor and inductor is a branch, and third branch is connected in between these two. The point is called a node which combines three or more branches is called a node. In nodal analysis, we made some assumptions that are we assume that there exists a node voltage between at the node point. Suppose that is V, and there is another assumption you made. The current is flows outward the nodes total branches. This is not a problem because of the current in all directions. At starting we assume that the current is flows outside the direction. It is not a problem. But finally you change the direction of the current. At initially we assume that by KCL. Okay, a question for you. Find out how many nodes in this circuit. Okay, this is my interview question, but I failed in this question. I will say answer at the end of the video. Okay, if you guess and comment the how many nodes in this. We know another concept to do nodal analysis. Suppose this is a battery, these two batteries. Find the current in resistance. Suppose battery is equal to 10 volts, and first battery positive is connected to second battery positive terminal, and first battery negative is connected to second battery negative terminal. Okay, the connection is like this. The voltage across the resistance is first battery voltage difference by second battery voltage. Because the same polarities are opposite each other, suppose this is first battery voltage is 10 volts and second battery is equal to 2 volts. The voltage across the resistance R is first battery voltage minus second battery voltage, because of first battery positive polarity is connected to second battery positive terminal. So by I is equal to V by R by Ohm's law, V is equal to 10 minus 2. The branch resistance is R is equal to assume that 1 ohm. Okay, this is equal to 8 ohms answer. Sorry, 8 amperes. Okay, you take another example. In this example, the positive is connected to negative of the second battery terminal. By Ohm's law, I is equal to V by R. We take same values at first circuit and 10 volts and 2 volts, and resistance R is equal to 1 ohm. Here you get 10 plus 2. How you get? Suppose for example you take two magnets, north pole and south pole, and each magnet have north pole and south pole. Suppose north are repulsion and south are repulsion. North and south only attract, and south and north is only attracted. So the battery strength is double when north and south are combined. In battery also same example, same principle workout. We get positive polarity and positive polarity are opposites, and negative polarity and negative polarity are opposites. When you connect positive, negative and positive, negative, then voltage is addition. So the first battery was the same example. First battery is equal to 10 volts and second battery is equal to 2 volts. The total voltage is equal to 12 volts. So you get 12 amperes as an answer. Okay, we take a problem and do a nodal, solve the circuit by the nodal analysis. Okay, battery and a resistance, the another resistance. There is a get another loop between resistance and battery. This is the circuit. Okay, the battery is equal to, first battery is equal to 10 volts and second battery is also 10 volts and 3 ohms resistance, 2 ohms and 1 ohm. This is the circuit. First step, you name the each points. This is A and the node is equal to B and reference node is equal to D. In this circuit we can have two nodes, one is B, the another is D. B and D, B is the node and D is the reference node. It is also called ground node. First and second step, we assume that the currents are flowing outward of the node from B node, from B to A and B to D and B to C. By KCL, Kirchhoff current law, I1 plus I2 plus I3 is always equal to the 0. At any node, I1 plus I2 plus I3 is always become 0. So I1 is equal to, we already know that at node B we assume that a node voltage V and node voltage is positive and ground node D is equal to negative. I1 is equal to the node voltage V positive connected to the first battery positive, so minus V minus 10 by the resistance R 1, and I2 is equal to, again I2 is equal to V by that node voltage by, there is no voltage across in the series with the resistor 2, so V by 2, and I3 is equal to, again the positive node voltage positive is connected to negative of the battery, so positive negative are addition, V plus 10 by V plus battery voltage 10 by, this is the voltage across the 3 ohm resistor by 3. Okay, by KCL, I1 plus I2 plus I3 is must be equal to 0. Okay, you substitute these values in the above equation. V by 2 plus V by 10 by 3 is equal to 0. Okay, by simplicity, V by 1 minus, we separate the terms by taking common as V plus 10 by 3, we separate like this, and we take common as V. At first term 1 is left and second term V by 2, so 1 by 2, and third term 1 by 3 is left. Okay, the remaining terms is shift to left side to right side, so minus will become plus, plus will become minus, so minus 10 will become plus 10 and minus plus 10 by 3 is become minus 10 by 3. Okay, we take LCM. By denominators have 1 plus 1 into 2 into 3 is equal to 6, so 1 by 1 is multiply with 6, we get denominator 6, so, and second term 2 is multiplied with 3, the denominator gets 6. So numerator and denominator is multiplied with 3. And third term denominator is 3. We again multiply with 2. We get, in third term you multiply with 2, the denominators get 6. So in both numerator and denominator is multiplied with 6. And we again take RHS terms also, we take LCM to subtraction. So 10 into 3, the LCM is 3, so 10 into 3. So we addition the terms. We get 6 plus 3 plus 2 is equal to 11 by 6. And 30 minus 10 is equal to 20. We get 20 by 3. So V is equal to 20 by 3. The 11 by 3 is shifted to right side. So it's become 6 by 11. So 3 and 6 are cancelled. 6 has 2. So 20 into 2 is equal to 40, and denominator is 11. So we get node voltage V is equal to 40 by 11. We substitute this node voltage at starting equations. We get current values. So we get node voltage is equal to 40 by 11. We substitute equations in V is equal to 40 by 11 in I1 and I2 and I3. We get current values. I1 is equal to V minus 10 by 1, and I2 is equal to V by 2, and again I3 is equal to V plus 10 by 3. Okay, we substitute V is equal to 40 by 11 in all equations. We get I1 and I2 and I3 current values. So 40 by 11 minus 10 by 1. So we again take LCM. LCM is 11. So 10 is multiplied with 11 by 11. 40 minus 10. 10 into 11 is equal to 110. 110 minus 40 is equal to 70 by 11. We get I1 value is equal to minus 70 by 11, because of we get minus 1. Again I2 is equal to 40 by 11 by 2, that equal to 40 by 11 into 2, that equal to 40 by 22. This is I2 value. Again I3 is equal to 40 by 11 plus 10 by 3. And you again take LCM. The LCM is 11, and 40 plus 10 into 11. That equal to 10 into 11 is equal to 110. 110 plus 140 is equal to 150 by 11 into 3 is equal to 33. The I3 value is equal to 150 by 33. We get I1 is equal to minus 70 by 11. So minus sign indicates that the current is in opposite direction. we assume that the current is outside the node, but the current is inside the node. Minus sign indicate the we reverse the current direction at starting assumption. And I3 and I2 are positive values, so we continue the same assumption. How to know these values are correct? I1 plus I2 plus I3 is always equal to 0. When we get 0, so the values are correct. If not, the values are wrong. Minus 70 by 11, I2 is equal to 40 by 22 plus I3 is equal to 150 by 33 is equal to 0. We take LCM. LCM is 66. Because of 11 table also cancel 66. 11 6 jar. And 22 table also cancel 22 3 are 66 and 33 and 33 2 are 66. So 70 into 6, because of 11 you get 6. Okay, 33 into 2. Okay, minus 70 into 6 is equal to 420 plus 40 into 3 is equal to 120 and 150 into 2 is equal to 300. By 600. Okay, 120 plus 300 is equal to 420. Plus 420 and minus 420 are get cancelled is equal to 0. We get 0. So I1 value and I2 value and I3 are correct. At starting I ask a question, find how many nodes in this circuit. If you guess 4, is wrong answer, because of it have only 3 nodes. This is node 1 and this is node 2. Then total is called ground node. Okay, the circuit is redrawn like this. The total points are connected, so the total 4 points are connected. 4 points is called a node. This is 4 node and 2 node and 3 node. If you guess 3, the 3 nodes are correct answer. If you guess 4, is the wrong answer. Okay, there is another bit for you. If you have n number of nodes in a circuit, if you require only n minus 1 number of equations to solve the circuit, to find the current values and voltage values, node voltage, to solve only n number of 1 equation. Please like and subscribe to my channel.